Hey guys, Orrick here. I'm going to do a video for worksheet 7 since Mr. Cedarstrom is subbing today for me. I thought this might help you out if you're happen to check out Google Classroom. So I'm going to work through a few of these problems and partially because it's a little bit like we're starting a new unit here. This used to be the first worksheet. It used to be called worksheet 1. It's really the second part of chapter 9 where we're going to start adding and solving rational fractions equations instead of just multiplying. So here's the whole point, and there's some that are just numbers, no variables in there, and some of these it might seem like we're going back to I'm not sure what grade, or elementary school or something. But to remind you how to add fractions, for one thing, it looks easy, but it's definitely more challenging than multiplying fractions. Now, when the fractions have a common denominator, then you can just add. So this fraction here, 1/5 plus 1/5, it just equals 1 plus 1 over 5, so it's 2/5. Subtracting the same way. Sometimes what I'm going to have you do when we get into more complex problems is change this plus to a negative, because sometimes you have to, when they aren't a common denominator, you have to distribute this negative number across a couple of factors. So it's not a bad idea to get in the habit of changing that minus to a plus. But this one, it's just 7 minus 5 over 6, so it's 2 over 6. And then you can reduce, in this case, since it's, we can make the fraction a little smaller. So that's kind of the general gist of it. And then, of course, it's going to get more complicated than that. Problem number 9, you'll see this a lot, LCD, least common denominator. So what number do both of these go into? And if you want, you can just start with factors of 8, and 8 times 1, 2, 3, 4, and until you get to 8 times 5, sometimes you don't have to multiply together. For instance, 2 and 6, if it was 2 and 6 in the denominator, you don't have to multiply the two together and have a denominator of 12. You could use the denominator of 6. But 8 times 5, 40 is going to be your least common denominator. So the whole point of this least common denominator, to get a least common denominator, is the multiplication identity. In other words, you can always multiply any number by 1. And so you probably don't realize when you do this, if you know how to do this, that you're multiplying by 1, but that's what you're doing. When you multiply this, and this is the process, to get 40 in the denominator, I got to multiply this by 5. Well, I can't just put, it's not 7 over 40. I got to make it the same fraction. So I go 8 times 5 is 40, and 7 times 5 is 40. And I'll change this plus to a minus also. And then over here, I'm going to have to multiply by 8 over 8. So I'm multiplying by 1, doesn't change anything. And so I'm going to have a negative 32. If I end up multiplying wrong, let me know tomorrow, or I guess it'll be Monday. And then plus negative 35 over 40. And now we have a common denominator, we can add them, and we have negative 67 over 40. And you can just leave it like that. It doesn't reduce down, don't write it as 1 and 27/40. Just, that's good. And now to get into one that's maybe a little bit trickier, just remember the number 2 is really the number 2 over 1. So the least common denominator is going to be 8. So I'm going to multiply this by 8 over 8. I'm going to kind of write right over this 14 here. 8 over 8. And so I'm going to have 16 over 8. That's 2. Minus, and I could write it as plus and negative, but with just one number, I'll leave it this time. Minus 13 over 8. And that equals 3 over 8. And to do one that's got a variable in it now, sorry about this Smart Notebook Limited mode. You can see it stays on the screen here, but if I scroll, it kind of makes it a little bit better. It has a common denominator, so I can just write this as 1 plus 1 over x plus 1. Just in the same way, x plus 1 is a single number. Just in the same way I've done any of these. I can go 32 minus 35, or I did 7 minus 5 over 6. I'm going to do 1 plus 1 over x plus 1. So the answer is 2 over x plus 1 is our answer. And I was going to do one more and then give you one more example. If you notice, this worksheet's got a couple of, I'm not going to do any of the factoring problems on there. I'm going to save that for, you guys can just use it for practice if you still need a little practice with the factoring. There's several difference of squares on there. Number 18 is one that's kind of neat because I have a common denominator, so it's easy once you have the common denominator. You have x squared plus 3x plus 2 over x plus 1, and you might think you're done. And remember, these are individual things. I can't do anything with them as far as crossing off a 3 and an x or anything like that. But I can factor this top one. Two numbers that multiply and give me 2 and add up to 3. So that really turns into x plus 2. This is one, I think that's like the final. X plus 2 over x plus 1 all over x plus 1 all over x plus 1. And now I can cross that off. So my final answer is x plus 2. So that reduces down quite a bit. And in other words, if I put 14 into this fraction, or if I put 17.5 into this fraction, any number other than -1, I can't put -1 in, that's an excluded value. But I put in any number, 1,485,360. Well, I forget the number I just said. So let's say I put 17 in here. I'm going to get 17 in for x. I'm going to get the number 19 because it's going to work all this out, and it's going to be the same thing as 17 plus 2. So any number I put in for x, it's going to be 2 numbers higher. All right, and just like maybe 1 or 2 more examples. I haven't even gone 10 minutes yet. So I want to show you what a little bit more complicated problem. I kind of mentioned this yesterday, maybe 2. If I have 1 over x plus 1, and I'm adding it to 1 over x plus 2, over x plus 2. And underneath this, I'm going to give you an example of, I think this was on a different worksheet, but 1/3 plus 1/7. Okay, so the common denominator in this one is 21, 7 times 3. Our common denominator in this problem is x plus 1 times x plus 2. So for this one, I'm going to multiply by 7 over 7 to get 7 over 21. This one, I'm going to multiply by x plus 2 over x plus 2. So if you get this now we're getting into the White Castle stuff. In other words, it's pretty tough to stomach. So we have 7 times 3 in the denominator, and this one I have x plus 1 times x plus 2 in the denominator. Now this one needs a 3 in the denominator, this one needs an x plus 1. So I'm going to go x plus 1 over x plus 1. And this one I would do, I'd multiply this by 3 over 3. And so this one's going to work out to be 7 over 21 plus 3 over 21. And so my final answer is going to be 7 plus 3 over 21, or 1021. Okay, so now I'm going to erase that. Just want to show you how analogous these two things are. Good word, Orrick. I suppose you should probably be teaching the English class. So now we have a common denominator, x plus 1 times x plus 2. On the top I have 1 times x plus 2, so I have x plus 2 times 1, which is just x plus 2 on the top. And on this one I got plus. I'm actually going to take that parenthesis off, and I'll show you why, because everything is going to get plussed. X plus 2 plus, now this one's getting multiplied by x plus 1, x plus 1. And this is all over the factor x plus 1 over x plus 2. And those two numbers are getting multiplied together, like 3 times 7 in that example I just used. So our final answer is 2x, x plus x, and then I have 2 plus 1, 2x plus 3 over x plus 1 times x plus 2. And let me see if I can do that. I probably won't let me do that. Well, I guess I can write it out. X plus 1 times x plus 2. I get kind of tired of writing the same thing. Some worksheets I can copy it, but the way these images are working, it's not letting me do that. So there, that's your final answer. I can't reduce it down. This is really kind of in parentheses also. So there's 3 different factors. One last example, I'm not going to work out the whole thing, but just to show you a kind of similar problem, just to get started on it. 1 over x plus 1 over x plus 1. This one, if you worked it out, the common denominator, the LCD, when we get done, it's going to be something over x times x plus 1. You don't have to multiply it out, x squared plus x. X times x plus 1. So this one, I'm going to have to multiply by x plus 1 over x plus 1. This one, I'm going to have to multiply by x over x. All right, 13 minutes, not too bad. Have a good day. See ya. Have a good weekend, because you're probably watching this on Friday. Or maybe you had some people over and it's Saturday night and you guys are rocking out to fractions. Have a good one. Bye.